A 12-foot ladder is leaning against a wall. If the top slips down the wall at a rate of 2 feet per second, how fast will the foot be moving away from the wall when the top is 8 feet above the ground? Okay, the top of the ladder is falling at 2 feet per second, and as a consequence of that, the bottom is moving to the right. If we let the vertical distance be represented by y and the horizontal distance be represented by x, what basically they are asking us to find is the derivative of x with respect to time when the top is 8 feet above the ground, when y is equal to 8 feet, right? Let's do it. So at any time, since x and y are part of this right triangle, due to the theorem of Pythagoras, x squared plus y squared should be equal to 12 squared. X squared plus y squared should be equal to 144, which is the square of 12. Now, if we take derivatives with respect to time of both sides of this equation, this is what we're going to get. Derivative of x squared will be the usual derivative that comes to mind, twice x, multiplied by derivative of x with respect to time, right? Because recall, we're taking derivative with respect to time, not with respect to x. And because of the chain rule, this is the derivative of the outside function, x squared, and that must be multiplied by the derivative of the inside function x, which is a function of time. Similarly, for derivative of y squared, derivative comes to mind is 2y, but since we are taking derivative with respect to time, we must attach dy dt. And this should be equal to derivative of this constant function, 0. Okay, now let's replace what we have and let's find out what we don't have. Twice x here, x I don't have, I'm gonna leave a space here. Dx dt is precisely what we will find out, right? Plus twice y. Y we have is 8 feet, right? 8. dy dt. dy dt is given by 2 feet per second, but since y is decreasing over time, this rate must be negative, right? Negative 2 feet per second. So be careful there with the sign. All that equal to 0. Now, when y is equal to 8, right? If you look at this right triangle, then because of the theorem of Pythagoras, x should be equal to the square root of 12 squared minus 8 squared, right? And that is something that we can compute with our scientific calculator. So I am using here our Desmos scientific calculator. So 12 squared minus 8 squared. The square root of all that is 8.94, rounded to 2 decimal places, right? So let's write this out. 8.94 here, 8.94. And this is precisely what we're going to place here, 8.94. Good. So now 2 times 8.94 is equal to following 2 times 8.94, 17.88, 17.88 times the x dt, which is what we're looking for. 2 times 8 is 16, times 2, 32, positive times negative, negative, right? Minus 32 equals 0. Transposing 32 to the right side, or equivalently adding 32 to both sides of this equation, we get this. And finally, isolating dx dt, dividing both sides by 17.88, we should get this, right? For dx dt. Let's compute this in our calculator. So we have 32 divided by 17.88. that is 1.789. I'm going to round it to 2 decimal places. So this should be approximately equal to 1.79. 1.79, let's write this out here, 1.79. And in the end, feel free to attach the units, right? Feet per second. And it's consistent with the fact that X is growing over time, right? It's positive rate of change. Okay, that's all. Thank you for watching. Please subscribe. More videos coming up.